Okay, so here we are looking at a regular pentagon. And by the word regular, here, what we're talking about is a polygon, a many-sided shape, where all the sides are the same length. And given that all the sides are the same length, what that also means is that all of these angles inside the polygon are also all the same. Okay, let's start looking at the exterior angle. Okay, where exterior means the angle outside. So if we extend each of these lines then what we get is 5 exterior angles. And each of these exterior angles equals 360 degrees divided by the number of sides. So in this case, that is 72 degrees. And now that we know that each exterior angle is 72 degrees, given that they're angles on a straight line, we know that each interior angle is 108 degrees. Okay, then the sum of the interior angles of a polygon, so the sum, that means all of them added together, is 180 times n, the number of sides, minus 2. So in the case of a pentagon, that's 180 times 5 minus 2, which is 180 times 3, which is 540 degrees. Okay, now moving on, any line going from a vertex or a corner to the centre of the polygon bisects or cuts in half your interior angle. So therefore, this angle here, which I'll colour in blue, that angle there is half of my interior. So that is 54 degrees. Okay? Equally, if we do another one of those, and another one, and another one, and one more, what have we got? We've got 1, 2, 3, 4, 5 angles at the centre, where altogether they have to add up to 360. So these angles at the centre, which I'll colour in green, just one of them, each of those are the same as one of my exterior angles. So 72 degrees. Okay. Now, let's see what happens when we then try to apply some of this to a typical level 2 style question. Okay, so here we are, where we are told that A, B, C, D, E, F is part of a regular octagon. So that is the key piece of information. Okay, where an octagon has 8 sides. So the first thing I'm going to do is, before I even look at anything else, I'm going to work out what one exterior must equal. So that's my 360 divided by 8, which gives me 45 degrees. So I now know that each and every one of my exterior are 45 degrees. And if you remember, I also now know that each of my angles at the centre are also 45 degrees, where this one here is in fact 2 angles at the centre, so he must be 90 degrees, even though he may not look it. But if you see, we have written here not to scale. Okay, so if we know that my exterior is 45, then we know that angle Y is 180 minus 45, angles on a straight line, so Y is 135. X, we've already said, is 45. And Z, if you remember, any line going from a vertex, a corner, to the centre bisects or cuts in half our interior angle. So Z must be 135 divided by 2, which is 67.5 degrees. And the one thing you probably need to take note of here is that you can have fractions of a degree in these styles of question. Okay, so that is a rather basic but fairly typical level 2 style polygons question.